Welcome everyone back to Through Inquisitive Kids. Starting from this video, we will be diving into lengths and angles, which are two very important factors of geometry that you're going to later encounter in high school. So for our Olympiad series, we will be looking at some key information to solving 4th grade, 5th grade Olympiad level geometry word problems. So the first thing I'd like to address is different types of angles. So there are first acute angles, and those are angles that are less than 90 degrees, right? And obtuse angles, greater than 90 degrees, and right angles, so angles that are 90 degrees, right? 90 degrees is very special because it is exactly 90 degrees, which is exactly like an L. So these are probably the three triangles you're probably really familiar with. Now I'm also going to start talking to you about, alright, so we also have straight angles. So straight angles, just like it's right there in its name, of course it's straight. But don't mess this up with a straight line, because usually it's going to have that to show that it's a straight angle. And it's 180 degrees. We're also going to look at reflex angles, right? So reflex angles are angles that are 180 degrees to 360 degrees, okay? And our complete angles are angles that are complete, which is one full circle, 360 degrees. So these are 6 really important types of angles that you need to memorize. Now we're going to be looking at 3 more concepts, right? So this is actually what you're going to learn in middle school, high school. It's also, some of it is also covered in our Chinese middle school math series. And this first one is called, so first I want to look at our complementary angles, right? So complementary. So complementary angles are two angles that added together equal 90 degrees. So they complement each other, right, to 90 degrees. Say I had angle 1 and angle 2, and angle 1 plus angle 2 equals 90 degrees. So I would say angle 1 and angle 2 are each other's complementary angles. Another one, of course, if there's 90 degrees, there also has to be 180 degrees. Those are called supplementary angles. And I like to remember this as, they supply each other with more degrees to get to 180 degrees. So if angle 3 and 4 added together equals 180 degrees, I would say angle 3 and 4 are each other supplementary angles. So these are always two pairs. And my final concept I want to go over right here is opposite angles, okay? So opposite angles, I should probably draw this out for you, are when there are two straight lines somewhere, right? And right here, angle 1 and angle 2, and this is angle 3, and this is angle 4. So in this case, angle 1 is angle 2's opposite angle, and angle 3 and angle 4 are each other's opposite angle. And not just because they're opposite from each other, but also because they equal each other. Angle 2 equals angle 1 and angle 3 equals angle 4. So why do they equal each other? Well, let's first try to prove that angle 1 and 2 are equal. So angle 2 plus angle 3, as you can see, equals 180 degrees, right? Because they're on a straight line. And I also know angle 1 plus angle 3 equals 180 degrees because of this straight line here. And since angle 3 and angle 3 are the same thing and they have the same sum, that means that angle 2 and angle 1 are the same. And you would prove the same way with angle 3 and 4 as well. So those are opposite angles. Okay? So I'm gonna just make this smaller. So kind of review what we just talked about there. So the different types of angles and the different types of angles and complementary, supplementary, we also have opposite angles. Remember, they're only opposite angles when they equal each other. Now I'm going to be talking about the angle sums of the interior angles and exterior angles of polygons. So let's first look at a triangle. This is a triangle, and its interior angles, as you might know, add up to 180 degrees, but its exterior angles add up to 360 degrees. So a lot of you might not really know what is an exterior angle. So if these are interior angles inside the shape, then exterior angles are going to be outside the shape. So we can take any side right here and just extend it, okay? So this part is extended, and connect that with a non-extended side, and this is an exterior angle. So is this. So is this, okay? So that's for triangles. For quadrilaterals, they're interior angles. Well, let's try to see. So how much triangles can this be split up into? Well, from the diagonals, that would be 2. And each of these add up to 180 degrees, and their angles are the same as those angles of the quadrilateral. So that would be 2 180s, which would be 360 degrees, right? And exterior is still 360 degrees. So the pattern is for interior angles, for exterior angles, no matter how many sides you have of the polygon, it's the sum of its exterior angles are always going to be 360 degrees, so that never changes. But for the interior angle sum, whenever there is one more side to that polygon, it means that there is one more 180 degrees. So those are the two patterns that I also need to cover with you. Now that we have gone over what I wanted to go over, we're going to look at the problem. Find angle A in the following figures. So angle A right here and angle A right here. Let's first do problem 1. So first, we just went over the interior angles and the exterior angles of polygons. So problem 1 is a pentagon, right? It has 5 sides, and we're trying to find one of its interior angles. So first, let's find what is the interior angle sum. Remember the pattern I said, one more side length the polygon has, and one more 180 it would be. Well, this is already 4 sides, so for 5 sides, I add one more 180 to 360, right? So 180 plus 360 equals 540 degrees. It means that the interior angles of a pentagon is 540 degrees, and the reason because of that is because it has one more triangle. So if we know that added together it should be 540 degrees, and we already know that there are 3 angles that are 90 degrees, and we know that that angle B is 140 degrees, and we also know that it's added to angle A. To find angle A, we just need to solve this, right? 540 is equal to 3 times 90 plus 140 plus angle A. So 540 equals 270 plus 140 plus angle A. So 540 and 140 both have the 40. I'm just going to cancel that out. So angle A equals 400 minus 270, which equals 130. So for the first problem, 130 degrees. Okay, so angle A equals 130 degrees. Now for problem 2, it's a little different because we have another angle right here. So let's first think about where is angle A. It's right here. And we just went over, so for the last problem, we had to first find the rule for the polygon's interior angle sum. So that's what we're also going to do for this. Okay? So it's actually a pentagon that was folded. But now you just need to look at this part. Okay? This part. And what polygon is that? Well, there's 1, 2, 3, 4, 5, 6 sides. So we need to add, because last time we got 540 degrees, right? So we add one more 180 to 540 to find the interior angle sum of a hexagon, and we will get 720 degrees. 720 degrees. And we know that the angles we already have, now we subtract the angles we already have from that. And the angles we already have is 190 degrees, actually 2 of them, plus 8, and this is a 270 degrees, plus 40 degrees, plus 130 degrees, and we're trying to find angle A. So let's first solve the parentheses. 720 minus something. There's multiplication, so I'm going to get rid of that. So 180 plus 270 plus, and I'll just add these two, which is 170, which also equals 720 minus, and then after solving the middle right here, 180 plus 270 is 450. 450 plus 170, 450 plus 170 is 620. And after we subtract that is 100, right? So for number 2, angle A equals 100 degrees.